Okay, welcome back. So here we are, we're Module 3. We're continuing on the pathway we've been on for the tools for data science, different libraries that we're going to be using. Matplotlib, scikit-learn, pandas, Seaborn. There's so many different ones that we're putting these tools in our tool belt, one piece at a time, and we're going to dig considerably deeper in modules 3 and 4. Now keep in mind, everything we're doing in this course is foundational for the courses that follow within the program. Okay. So put the time in now. It'll make things a whole lot easier in coming semesters. All right. It may seem like, man, it's a lot of time that I'm having to invest in this. It is, and it's well worth the time though. Okay. So with that said, we're going to have some rehash on what we're dealing with here, and then we'll have some new stuff. Okay. So we're dealing with the tools, what it is we're using. We're using the Python language, Jupyter notebooks, and Colab. We've got Kaggle that'll help you. We had that first one, and we've got a second one coming now for some more bonus points, and that'll be a Kaggle Pandas walkthrough or short course. Okay, so you'll have a certificate associated with that for some bonus points. And today we're going to deal with Pandas and more, and how to do things right. Okay, so with that said, let's do a quick little review. What is data science? Okay, cross-disciplinary set of skills. This is coming from Jake Vanderplas, the author of the text that we're using, and we're going to end up adding in another text, maybe two, to supplement what we're doing. It'll all be part of the O'Reilly library, if you will. Okay. So here's what it is that we're doing, and we're going to keep coming back and focusing on this cross-disciplinary set of skills. All right. Now, we've looked at this, how it ties together with the hacking skills. And keep in mind, when we talk about hacking skills, we're talking about programming, the actual coding aspect of it, the domain expertise, the fact that we can throw statistics and probabilities into it. That's what gets us in data science. We're familiar at this point based on the journal article that provided previous module, what data science means, what it is. So who's a data scientist? And we've got 3 acronyms that we need to memorize. I mean, we don't really have to memorize them, but each one is a hierarchy. We'll start out with a DIKW. Data, information, knowledge, and wisdom. They all build one on top of the other. And we're going to come down to PPDAC. Problem, plan, data, analysis, conclusion. We start here with a problem. What is it? What's going on? We need to understand and define the problem, how we go about answering whatever the question is or obtain the result that we need. Let's plan the whole thing out, start to finish. What data do we need? All right, we know what data we need now. We need to collect it, manage it, clean it. Once we've done this part, now let's move on to the analysis part of it. We're getting into our EDA. From there, we'll come up and derive some conclusions, some insights. So that's our cycle, our framework. Okay. Now it's cyclical. We may realize, oh, let's go back at it again because we got something wrong. Now, we don't have an expectation that we're going to be right the first time every time. So we understand that things are going to be cyclical. So in this last one, DMD, WHCC. Okay. So we start out, we've got our data. From there, we need to clean it, understand it, transform it, model it. May have to go back, get a better understanding on it, transform it, model it again. So we may get caught in this a little while on our EDA. So this is where we're at now with what we're doing, is this EDA part of it. Once we got EDA dialed in, then we'll go ahead and deploy and maintain the model. And this is the machine learning aspect. Communicate the results, or let's go back and do it all over again. Okay. So, I've got a video that I provided of Cassie Kazarkov, and she's the head of decision intelligence at Google. Now, when we look at what our individual data science adventure is going to be, are you making decisions? Nah, I'm just curious. Let me go meander around. Or, yeah, I need to be able to make decisions based on whatever I'm doing. Lots of them? Only a few? Is there uncertainty? Yes or no? There's a lot of questions we got to ask along the way to get where we want to be. And we're steady changing as we go. We may realize, well, I thought there was no uncertainty. Oh yeah, there is. So there's cycles that we may be going through. Okay. So we've gone through and we've looked at the fact that we've got so much data available to us today. So many open source tools. We can get at code and data sets so easily. And we saw code from Christian Garvin, data sets in Kaggle. There's so much that we have available to us. And there's so many use cases that, okay, let me go see what they did. Maybe I can reuse that and apply it in a different domain. We've got computing platforms that are so dynamic, so much faster, and we've got those lower barriers to enter that's what's driving this growth in data science and machine learning. Okay. Now, Anaconda, I'd mentioned previously, and Anaconda's been around for a while, and I don't mean an immensely long time, but it's been around for a while. It's widely adopted. I don't suggest it for us. There may come a time, a specific application, where you may want to go install Anaconda, and if that's what you want to go down, you're more than welcome to go do it. Just ask that for the courses that we're dealing with here within this program, we stick to the platforms that the tasks are assigned to be performed in. Now, in the past, students have decided, I don't like this tool, I'd rather use something different. Now, you're entitled to use whatever you want. Does that mean you're going to get credit for it if you chose to submit it in a different format? No. Odds are you're not going to get any credit for it if you submit it in a format other than you've been instructed to use. It'd be like you go to order dinner, it comes time to pay for it, and you want to pay them in cheese. And they say, no, we actually want money. I said, well, this cheese is worth money. And they said, no, not to us. And you end up either washing dishes or going to jail for failure to pay the bill. So there's an agreement up front. Here's what the expectations are. Here's what you need to do to receive credit for these tasks. These tasks are chosen, or these environments are chosen based on a lot of research and past history of becoming familiar with what works for the way the program's been developed and being instructed. Okay. So Anaconda, it's there. We are not using it, but it is still there. Well, I'm not going to ignore and act like it's not a tool that can be used. We're just choosing not to use it. We're using Kaggle. We've got 2 bonus point tasks assigned with it. Okay. We've been working through the guided tour, and you'll notice now that the guided tour is longer than it was before. We're up to, I think, 8 phases now in the guided tour. So we started out with, let's get GitHub set up, Colab set up, to get used to how to perform certain tasks. Let's get a refresh on Python. If I've got deficiencies, let me address them. And it's getting stronger and getting stronger. We've got the 2 bonus points so far. The first one, that's Python Kaggle. Like I said just a little while ago, we've got a new one coming up. You'll see the assignment there. And that's Pandas, another one in Kaggle. Okay. So the tools that we're using, all right, we're using Colab. We've walked through it. We know how to get to it. Everybody should be all set up and running when it comes to Colab. It's very low resource dependent on your part. If you have some massive data set that you are using a very aggressive algorithm to perform some tasks, that algorithm may require massive amounts of RAM. It may require massive amounts of processing capacity, GPUs. If you don't have it, well, you can get that with Colab. You may not be able to get the capacity you need with the free version of Collaboratory. Personally, with the research that I'm doing in medicine, cancer diagnosis, I've got a subscription. I think it's only $10 a month to be able to have more GPU and more RAM, given the different scenarios that I'm going through. In some instances, it could determine whether your algorithm will run, or your program that you've created, the solution you're trying to run, or your model that you're working with. It may be the deciding factor on whether you can actually get it to run or not. What made me choose to switch was that I got into a task that I was working on for a grad course that I took a few years ago, and I didn't realize the complexity of the algorithm I was using. Had to rethink what I was doing because I was not going to live long enough to run the code. Not that I have any expectation I'm going to die in the short term, just that that code would not be done running within about 50, 60 years, given the resources that I was using to get it done. Okay. That's a discussion for a whole different course, and we'll deal with that in COP3530. But I digress. Let's jump back to where we were. We know where Python came from. Guido van Rossum created it, first released in '91. From there, we jumped over to IPython, Fernando Perez. Then that led us into Jupyter Notebooks and our IPyNB file extensions that we're dealing with now. So we've got what we'll call our data science stack. So we've got our notebooks. I could use Visual Code. Whatever my development environment is, it could be Anaconda, pip. All right, so these are what we're interacting with. Over here's our language and the libraries that we're dealing with. I don't need to use all of them in some cases. In some cases, I may have to use all of them. All right. It's the text that we're dealing with. But the first 5 chapters with this Python, NumPy, Pandas, Matplotlib, and scikit-learn. We've got a lot that we're dealing with. And these are all different tools associated with data science. Now, we need to get an understanding of how to do things the right way. What's right? That's a matter of perception. Could be following the lead of somebody else that's been down the path and they found out the hard way what's the right way and what's the wrong way. But we need a solid conceptual foundation for what we're doing. We need to be fluent with Python data science stack. We've got programming and documentation associated with whatever we're using. We've got to have an awareness of the biggest traps and sources of confusion that may exist with whatever we're trying to get done. We need to communicate, and with the help of, or I should say communicate beyond and with the help of numbers. We're not just saying, here's the data, here's numbers. We need to visualize things. And we need to learn from what works, what doesn't work, examples that we've seen. Sometimes things will work in one domain and they won't work in another. They may work in medicine and not work in marketing. And when I say they may work, I'm talking about, in this example, conveying the message, how you're interacting with the customers, the clients, whatever it may be. One model may work in one domain and it may not work when we switch over to something else. And that's, we're on the programming side of it, looking at it that way. Okay. So we've got examples. There's a little URL. You can go look at what works. Okay. Christian Garbin, we started talking, referencing his content from machine learning applications conference that he presented at a few years ago. We started with the EDA aspect, and we've walked through that. We dealt with pandas, we looked at the shape, the columns, the data types. We know what the head is, how many rows a head function will return, and how to modify it to increase or decrease how many rows are returned. We dealt with what is null will tell you, and how to count or determine how many for each feature or column using that sum function. We know describe will give us statistical values associated with, or I should say descriptive statistics associated with the data that we're applying it to. Unique will tell us how many unique values are in a specific column or feature. We've gone through already now statistics and data science, that second part of it. Okay. Now that second part of it, we got where we dealt with seaborne box plots. We dealt with the data frame, how to filter out things like we don't want to deal with people that are over a certain age. We don't want to deal with education levels that are below 12. So we narrowed down what we were dealing with. We dealt with pair plot to see relationships of all the attributes, and it was similar to what I showed you in the initial walkthrough where we discussed the first assignment, that first video that we recorded relative to the assignment, where we can go through and see the relationship between the different features. Okay. There's different ways to go about it, and the pair plot is one way. All right. We use the cut function to go through and group attributes into larger categories. One of the examples that Christian had said, man, this is an awful busy plot. Let me go ahead and clean things up by using a bin to group attributes into different little categories. And we saw an example of that in the Module 2 lecture, where we walked through and looked at how that played out by cleaning up the visualization of the data. Okay. So at this point, if you've got questions, reach out, ask them. We've got discussions. We don't have discussions in every module. We've got just about every other module. So the discussions can span across. If we don't have a discussion in Module 2, that doesn't mean you can't access the Module 3 discussion. Okay. Got questions, use them. We've also got a frequently asked questions discussion thread going on. That was not graded. So always ask questions when you come up with them. So this first book that we're dealing with is the Vanderplas text. Now, one of the things that you got available to you is something that we pointed to it in the guided tour. I've got a link in the resources in Module 3 where you can access Jake Vanderplas's GitHub repo, and in his repo he's got a multitude of different notebooks that we can go through on NumPy, Pandas. There's just so many notebooks there that we can go through to go practice, see how things work, examples of how these tasks are performed. Okay. Now, when it comes to NumPy, we can go through, and the first one's just an intro to NumPy, understanding data types. So we've got 9, 10 different notebooks there that walk through using different aspects of NumPy. Now NumPy, the highlights of it, the primary reason we want NumPy is for the array. We don't have an array in Python without NumPy. I said, well, why is that a big deal? So, in Python, if we don't have an array, all we have is a list. How do an array and a list, how do they differ? They look the same, but they're not. Some of the differences are an array is contiguous in memory, meaning the memory allocation in RAM is one right next to the other, next to the other. That's an array. A list is non-contiguous. Things are just spread out all over in memory. Now, if things were spread out all over, as opposed to being all in one place, do you think it's going to take longer to go access them? What if you had things spread out all over your house, and all the different rooms of your house? Stuff you need to make dinner. That's an array. No, that's a list. A list is spread out in all the rooms. Can you go get me the spatula that's over in the bedroom? The frying pan, it's out in the garage. If we're dealing with an array, everything's right there in the kitchen. More efficient. That's one comparison. There's another comparison. I'm not even looking at memory allocation. We look at what's being stored. In an array, sequential data of the same data type. In a list, sequential data, when I say sequential, it's pieces of data stored logically one after the other. In a list, it doesn't have to be the same data type. In index 1, it could be a string. Index 2, it's a float. Index 3, it's a dictionary. Wait, what? Data types, when they're not the same, it makes it very difficult to work with them. Because you run up against things that you don't expect. So we want to use arrays in data science. So we use NumPy so we have an array available to us. We can index things. We start in 0 and go beyond. We can have subarrays in the array, so I can have an array of arrays. I can concatenate arrays. I've got different attributes and functions associated with the arrays. I can slice the arrays up, I can reshape them, I can split them. I've got functionality associated with each of them. Okay. So, as I said, NumPy, contiguous in memory. That's our array. Python list, well, there it is. And they all point to different places in memory. It's all over the place. The data types available to us in NumPy, we've got more. Not like we've got exponentially more. We've got more. 2-3 times the variety of data types available when we add NumPy. We've got functions available to us in NumPy. Whether it's add, power, divide, multiply. We've got to be careful about how we go about things and understand when we're dealing with arrays. Dealing with an array is different than dealing with a float or an integer. We've got special rules that we have to deal with because we're going one index at a time. We can use specific functions that make it a little easier for us, but we still got to remember, I like to compare it to boxcars and a train as opposed to a single car. Right. So we've got our array, and when we add things together, 3 plus 5, wait a minute, what's going on here? We've got to use certain functions to be specific about how we're going about doing things so that when we perform math, it is math as opposed to reshaping an array. Okay. So we've got different rules that apply, and we just need to understand that when we're dealing with arrays, we're dealing with sequential data. It could be one-dimensional array, two-dimensional arrays, or what we'll call a matrix. Either way, we've got to look at the dimensionality and how these things go together, the shape of it. Okay. We've got comparison operators available to us in many languages. We've got functionality in NumPy. np.equal is an equivalency operator, or not equivalent. It's less than equal, greater than equal. So we've got other ways to do things when it comes to functionality rather than using the operators. It's just tasks that we get used to, and we've got it in those videos, or I should say not the videos, but in the notebooks that are available. As I said, I've got the link to the Vanderplas notebooks in the Module 3 resources. Okay. So if we go through and we start doing things hands-on in these different notebooks in the guided tours, go play with them and get used to it. Go through the bonus points in Kaggle. Get familiar with Pandas. It's a great walkthrough. It doesn't take that long to knock that certification out. Okay. So Pandas now, it differs from NumPy. Pandas gives us the ability to not just work with different data types, but now we're dealing with data structures. And I don't mean data structures. Technically, an array is a data structure. It's sequential data. But we're dealing with more than one dimension. We're dealing with something that's two-dimensional for the most part. We're going to deal with data frames. And when we start dealing with data frames, that's the primary data structure we're going to be using in this course. The data frames will allow us to bring in columns and rows, features and rows, to get an understanding of what's going on in the data. So here's a link to Kaggle. This is what it's going to look like when you're all done with it. You've got to go through and complete each task one by one to be able to get to the end. And you've got to upload that PDF that they give you at the end to get credit for the bonus points. Okay. Please do not try to go through and Photoshop and get it done that way. It's been done, and those that have tried have failed, and it was not pretty. When I say it's not pretty, not just was their Photoshopped cert not pretty, but the result of documenting the incident academically and it going through administration to take action on somebody that was presenting something that was not real. Okay, so we went through, we talked about the different notebooks associated with Pandas, with NumPy. We've got 14 of them here now associated with Pandas. Some of the stuff we've dealt with, we saw in Christian Garbin's first two notebooks that we dealt with in his GitHub repo. Some of this other stuff is going to be new to us. Okay. So when we're dealing with Pandas, we're dealing with multi-dimensionals, but it's not necessarily just multi-dimensional. We've got an array in NumPy. We've got what we'll call a series in Pandas. Okay. Our primary focus, as I said, is going to be a 2D array, or what it's compared to logically, but it's a data frame. It's a two-dimensional data structure, row indices. We've got columns that we can name them whatever we want to name them. It's just an alias for the column. And we look at these columns as being features with what we're doing in our data science, data analytics. Okay. Now, Pandas uses NumPy. Wait a minute. Panda and NumPy are separate. They're different. Yeah, they are different. Now, we may use NumPy to do different things that we're going to do. Pandas uses NumPy for some things it does. So there's times that we'll use a library and it's also using another library that we may be using. There's some redundancy going on there, but it's okay. So we've got in Pandas, we've got an index object, and we've got this idea of something that's mutable and immutable. And you can change it or you can't change it. Okay. We'll deal with these things on down the road, but initially as we're going through this, we've got data that's indexed. It's in some specific sequence. Now, programming, we're looking at it 0 is where we start. So the first index is 0, 1, 2, 3. The rows will be 0, 1, 2, 3, 4, and so on. In math, we start with 1. Programming, we start with 0. We're talking about indexing. It's the sequence, 0 on. So we're saying that I'm going to import pandas as PD. We've got a series, which is it's like an array. And we're saying there's an index associated with it, 0, 1, 2. Well, we're replacing that 0, 1, 2 with an A, B, C, D. So we've created an index here, and here's the value associated with those indices. From A to C, there we go. Show me index 0 to 2. 0, 1. That's all we're getting. We don't get 2. 2. And it provides us what the data type is or what we're dealing with. Right. Now, we've got something that's different and this will take some of you a little getting used to. We've got lock and iLock. There's IX, but it's deprecated. We're not using it anymore. So we're saying lock and iLock. And they help us get into rows. Okay. So indexing is how we go through column by column. Slicing refers to rows, and iLock is us slicing. We've got an entire notebook going through and getting used to that. Okay. So we've got a lot of different stuff that we're getting hit with now that we haven't dealt with before. And Pandas, similar functions, but they may be named different. So we're thinking, no, wait a minute. we just dealt with NumPy. I've got math functions that come with NumPy. Yep, we do. We've got math functions that come with pandas too. We may have other math functions that come in matplotlib too. So when it's all said and done, we may have 3 different functions to perform the same task. Now remember, we came up with that alias thing where we had the PD, we had the SNS. We do that for a reason. Because if I didn't put that object up front, what library we're getting that function from, if we weren't explicit about where the function's coming from, we may not know which version of, let's say, the add function. I may have 3 different add functions. Which ones do you want to use? You want to use the PD one? The NumPy one? Which one? The PD, the NP? Which one do you want to use? Is there a built-in one? Could we have used another one? So we've got to be explicit, and we'll do the PD.add or the NP. Whatever it may be. So we've got to be specific there, so there's no confusion. It'd almost be like I had 3 people in a class named John. I said, John, what do you think about this? And at the same time, they all answer me. We don't want that. Okay. So we put little aliases so we can distinguish one from the other. np.man. So we'll find out, is it not a number? We've dealt with how to handle missing data. In Notebook 3.4, how to detect, remove, and replace null values. Is there null there? Not null, is null. It's the opposite. Drop NA. Get rid of the ones that have NA. Fill in. Fill in gets kind of sketchy. So we don't have a value in there. Just get rid of that record. That record may have, or that row, may have other things that are important. And if you drop that row because it doesn't have some value that may not be a big deal now, is there another way? And the other way that we can deal with things is what we call imputing a value. And essentially, we look at similar rows and say, hey, are there any other rows that have everything else the exact same? And if so, let's average what would be there and impute an averaged value. Now that average could be just for similars, or it could, what's the average overall, and we'll impute the average overall. And that won't throw us off statistically in any kind of significant way. But it could have an impact, because now we're just saying, I don't know what's there. Let's just go ahead and throw something in there so we can keep going. Well, that's something that we imputed may not be what was actually there. And for whatever reason, we didn't get, when data was collected, we didn't get the actual value. Okay, so this fill NA, it's a double-edged sword. It could help us or hurt us. Okay. So we've got to be sure when we're dropping null values or swapping things out, imputing them, we need to think about the gravity associated with how many rows are we dropping? What are you talking about? We're dropping 40% of the data because some things were missing. that may really throw off everything else we're doing. So we've got to be sure before we just go getting rid of data. And if we're going to impute data, we've got to be sure about how we're going through doing it. Okay. So we've got indexing, and we'll deal with indexing as we go through. I may concatenate different data sets together. We can use an append method to add to the end of a data structure. We've got joins where we can join things together. Where do you want to join it? How do you want to join it? Do you want to overwrite things? What if there's duplicates? Can you have duplicates? There's a lot that comes into mind, I should say, that comes into play when we start trying to join together different data from different sources. Okay. So we've got these statistics, the low-level statistics that we've dealt with before. We've got functions now associated with them. When we talk about aggregation, what we're looking at when we're trying to take one thing and then end up with something else, how's this going to work? Okay. And a lot of it applies to using pivot tables, how we're going to use the data, what we're looking to get from it. Okay. Now, I'd said before, we can have statistics that appear to say something that's not actually happening just because of how we've presented to the data visually. When we look at this, like, wait a minute. Clearly, there's more men than women in this data. And the men, more males are being born each year over time than females. We've got within pandas a massive amount of functions that allow us to go through and handle our strings. We've got a massive amount of them that allow us to deal with the data frames, deal with series, and we just get used to them over time. Now, similar functions exist in Python. Now we're dealing with pandas. So, like I said, we've got to be careful if we're using functions. Where's the function coming from? Where does it live? Is it built into Python, or is it part of an add-on library like Pandas, NumPy, Matplotlib, whatever it may be? So I've got to know where's that function coming from, what's it need from me, and what's it going to give to me or do for me. So we've got a regular expression module. So we've got a match, and it'll return us a Boolean. Are they a match? That's just a comparison of sorts. We've got different regular expression modules that we have available to us. It's not something that we're going to use a whole lot in what we're doing, but it's part of that walkthrough that we're doing. Okay, there's a massive amount of information you're being hit with in a very short period of time. Do you have to know all of it? No, you do not have to know all of this right now. you need to know where it's at. Should all of a sudden something come up, oh, I'm not sure about that. Oh, wait a minute, I've got a resource. I've got a notebook that I know it's got that in there, and I can go in there and I can refer to it. Okay. So now you've got tools available to you to help you use other tools. Okay. So we've got a variety of different string methods. There are a variety of string methods built into Python as well. Okay. Now, one of the things that we have available to us is time series. We've got date time in Python. Pandas has got it built into it as well. And we've got to look at the formatting of time. Now, date time uses the system clock, and it'll help you find out what time it is now down to the millisecond. And we can get whatever time, date, whatever it is that we want, and format it in a specific way. That time stamp allows us to work with things in a time series. So if I timestamp what's happening, I have a series that I can sequence things based on their timestamp. Okay. So it's not something we're going to dig deep into in this course, but you've got that available to you. You know where to look for it now. Okay. So within time, specific codes or abbreviations that tie to a specific description or something that we normally talk about: minutes, seconds, milliseconds. Who would think L is milliseconds? We know now. Okay. And all of this is in those notebooks. Okay. So I can look over time, say, all right, here's what's happening over time, the time stamp, and I'm looking at data. 1 year rolling trend, 1 year rolling mean, the standard, what was the inputs. So we can work with time series to get a decent visualization of what's happening. We format the time and do our comparisons. All right, so we don't have to dig into 312. Our next one that we're going to be dealing with, we'll pick up and deal more with it in Module 4, is Matplotlib. And that'll be part 7 of our guided tour, dealing with the Matplotlib. Now, this is primarily visualizing, plotting our data. Okay. We've seen it already, and we've got here 16 different notebooks associated with Matplotlib. Okay. It also uses NumPy, much like what we saw with Pandas. And it also works with SciPy. So there's a lot going on. It's been around for decades. And it's a powerful tool. Get real comfortable with using it. It's easy to use. We'll deal with histograms, error bars, scatter plots, line plots. And then we'll deal with Seaborn as well. Okay. So with that said, let's leave this one. I'll pick up on another video, another lecture behind this one. We'll end this one in just shy of an hour. Do one more, and that one will have to do with likely some more Christian garbing. Okay, so I'll see you in the next lecture.